Okay, so hi and welcome. So mainly today is our second day, and we mainly today's class I will try to discuss about the some advanced topic on remote sensing analysis using the Google Earth Engine. So basically, first day I will try to discuss about the some basic things on Google Earth Engine platform. So different types of how you can easily the basic things of the Google Earth Engine, such as the JavaScript programming, as well as also we try to discuss about that how you can easily import the shapefile, how you can easily import the boundary shapefile. We also try to discuss about this part. Okay, so I think I can also get the some sound from your side, such as
Can you
it.
repeat, please?
So I can get some sound from your side.
Yeah.
Yeah. So
I
if
hear.
yeah, so you can okay. So if possible, you can use your headphone. Then I think it's also better. Otherwise, it's also echo.
Oh, I don't understand a little bit.
So you can use your headphone, or then it's also better. Yeah. Otherwise, it also
Oh,
echo, return the sound from your
okay.
device.
Okay.
Okay. Okay. So let's go. So now we'll try to. I simply share my screen.
Okay.
Okay, so now can you see my screen? Yeah.
Yes.
Okay. Okay. So basically, today is our second day,
Mm-hmm.
and in this second day, I will try to discuss about all the topics. So first of all, I try to discuss about that how can easily filtering and displaying the satellite images, mainly Landsat and Sentinel imagery. How can easily filter and displaying the satellite images. Then how can easily use the different types of band combination. How can easily export the satellite imagery. Okay,
Mm-hmm.
and then how to import, filter, reduce, clip, and display the data in Google Earth Engine platform. How to make the time series chart of the NDVI using the MODIS satellite imagery. How to export any shapefile and calculating any indices from the satellite images. So let's go. First of all, Earth Engine public data catalog. So mainly, it's a Earth Engine public data catalog. In this Earth Engine public data catalog, we can get all of the remotely sensed data, such as Landsat, Sentinel, MODIS, different types of train dataset, land cover dataset, atmospheric dataset, and it's daily updating. This dataset is daily updating. Here we can find out more than 200 public dataset, more than 4,000 new images every day, as well as more than 5 petabytes of data and more than 5
Mm-hmm.
million images we can get from this data catalog. Okay, so we can easily get
Okay.
the access the data catalog from this link. So I just simply open a new code editor from here. I simply open a new code editor. So I simply go to my code editor. Then I can easily find out all of the Earth Engine public data catalog. Okay, so here you can see the search place and dataset. So just I simply click on the search place and go to the browse data catalog. You can see browse data catalog. So mainly from this data catalog, I can easily get all of the data sets such as Landsat, MODIS, Sentinel, all of the data set I can easily get from here. Here you can see
Mm-hmm.
different types of surface temperature data set, climate data set, as well as atmospheric data set, weather data set, different types of imagery such as Landsat, Sentinel, as well as also MODIS, then different type of high resolution imagery. Also, a lot of data set you can easily get from here. Okay, so suppose in this time you can see when I click on the Landsat, here I can get all of the Landsat image collections, such as you can see the Landsat 9,
Yes.
okay, Landsat 8, Landsat 7, ETM plus sensor. Also is Landsat 5 TM, Landsat 4 TM, Landsat 1 to 5. So all of the image collection we can easily get from the Landsat. When I click on the Sentinel, so here I can get all of the Sentinel image collections, as you can see the Sentinel-1 SAR data we can easily access from here. Sentinel-1 multispectral instrument dataset. Here's the Sentinel-5. So Sentinel-3. All of the things we can easily get. Okay.
Yes.
Okay, so I can get the some sound. Okay, so I can, when I talk, I can get the some reflection from your side.
Okay. Okay. Yes.
So
But listen, you know.
okay, okay, okay. So let's go. So if possible, can you use your headphone or can simply ignore this noise? Can you use your headphone?
No, not yet.
Okay, but it also reflected some sound
Mm-hmm.
when you
To the
can
side.
when you are wearing the earphone or headphone, then it's not happened.
Okay.
Okay.
Mm-hmm.
Okay, so in this time here you can see here I can get all of the data collection from here, and when I click on the Landsat, you can see here I can get all of the
Yeah.
Landsat image collection. Thus, as you can see, I can get the Landsat 9,
Yeah.
Landsat 8, Landsat 7. So in this time, I try to show you that how you can easily filtering the, suppose I want to work with the Landsat 9 image collection. I simply click on the Landsat 9. So here I can find out all of the image collection such as Landsat 9. You can see surface reflectance, top of atmospheric,
Yes.
raw image. So you can see surface reflectance image. So mainly this surface reflectance image we are using for identify the land use and land cover classification map when you want to use the surface reflectance image. Also you can see top of atmospheric
It's all.
image, raw image. Okay. So suppose in this time I want to work with the surface reflectance image. Okay. So I simply click
Okay.
on the surface reflectance. So here I can get all of the surface reflectance image for the Landsat 9. I can get all of the information. You can see dataset availability date. We can get the dataset between this time period, year of 2021, October, 31 October from 2023, January, 1st January. Between this time period, I can get all of the satellite images from Landsat 9 surface reflectance image collection. Okay.
It's already with atmospheric correction.
Yeah,
Yes.
already it's atmospheric correction and all of the correction is already completed in here. In this time I
Mm-hmm.
just work with the satellite images, so I don't need to use the atmospheric correction or other things. I don't need to need in this time because it's already done. Okay.
Yeah.
And this dataset provided is that USGS, and this is the Earth Engine snippet. Okay. So mainly this Earth Engine snippet, it is the unique ID. Okay. It is the unique ID of this image collection. So every image collection has a some unique ID. It's called the Earth Engine snippet. So in this time, I want to work with this image collection. So in this time, you can see this is my code editor, yeah, and it's my image collection. Okay. In this time, this image collection, I need to import my code editor. Okay. So
Yeah.
just I simply copy this Earth Engine snippet from here. Just I simply copy this line, just copy and paste here. Okay. Now I simply take a variable name. So I put a variable name, suppose L9 or Landsat 9. I simply put this. In this time, this is my full image collection. Okay. This full image collection is stored in this variable L9. Okay.
Okay.
I want to check it. How many images are available for the whole world between the time period year of you can see between this time period year of 2021 10
Yes.
31 October from 2023 1st January. How many images
Yeah.
are available for the whole world? I want to check it. So just I simply use here the print function and then call the L9 because this variable is stored in my full image collection. Okay. I simply use the
Okay.
size function. Size. Size function is determine how many images are available. So I simply click to the run. Now you can check. I can get the result. So it computing how many images. You can see here. You can find out the
Oh.
large image collection. Okay, for the whole world.
World.
Yeah, for whole world. In this time, we can get this image collection. look like this. Okay, in this time
Yes.
I can get the result for the whole world. But suppose in this time I don't need for the whole world, I need only for my own region, such as Dhaka city or Ukraine or
Okay.
any city I want to need. So previous class we also try to show you that how you can easily import your shape file. I hope you can easily
Yes.
understand about that. In this time I simply import my shape file. Suppose I want to work with this shape file. I simply import the shape file. So I simply take a city of Ukraine, and then I want to
Okay.
get this Landsat 9 satellite imagery for this cities. Okay. So just I simply import the all of the cities. I simply import in here. You can see. So now it imported. From this, first of all, I simply show the filter my cities. I simply take a variable and put the variable name suppose city, and then simply call the table. I just filter it. How I can filter? Earth engine filter. Equal. What's equal what? I simply go to this attribute table from here.
Yeah. And filtering
Yeah.
this.
Then getting on the feature, I simply go to this cities. Suppose name one. I simply copy and paste here. And then I simply also call this name with city's name. I want also need.
Okay.
Suppose I want to need the cities for suppose this cities. Sorry, okay, sorry. And then I simply paste here. Okay. So now I want to show this result. So I simply use here the map dot. I want to add a layer, and then call the city and click the run. One layer will be added here. You can see. I also need to focus the center. So I simply use here the map dot center object. Okay. So previous class I also tried to discuss about this function also.
Yeah. Yes.
So now you can see I can get my city. Okay. So I want to need this Landsat 9 satellite image collection for these cities. Okay, suppose this is the cities. I want to need the Landsat 9 image collection for these cities. So here I can see for the whole world, you can see for the whole world I can get this collection. But in this time, I want to need only for this image for this boundary. Okay, and this boundary is stored this variable city. Okay, so for this I simply take a variable. Suppose this variable name I simply put the filter region. You can use any variable name, no problem. I simply call the L9. Okay, L9 because is stored all of the image collection and paste here. I simply use the function filter bounds. Okay, filter bounds with my city, and my city is the Sarkesi. This Sarkesi is stored the variable city. Okay, I simply copy and paste here. Okay, so in this time what happened, you can see L9, this variable is stored the large image collection, okay, for the whole world, but I don't need for the whole world, I need only for the city. Okay, and this city is stored variable, this variable name is the city. So just I simply use city. So now I want to check how many images are available for my city. I want to check it. I simply print and then simply call the filter region and simply use that the size function again. In this time, it show the result how many images are available for my city. I can get total 143 images for this region. Okay, I want to get. Okay, so in this time, suppose from 143 images, I want to need only for those images, which image will be not more than 1% cloud cover. I also filter the image property or image metadata. I also need to filter. Okay, so for this, I just simply take the another variable. Suppose this variable name is the filter metadata. You can use any variable name. Okay, then I simply call the filter region because this variable is stored 143 images. Okay, from 143 images, I want to need only for those images which image will be not more than 1% cloud cover. Okay, I simply use here the filter metadata, and then you can say simply get the name, operator, and value. So what is the name? Name is the image properties name. You can get the image properties name from here. You can see image properties. Okay, so just I simply work. You can see different types of image properties. I want to work with the cloud cover. Okay, I want to need the less than 1% cloud cover. So just I simply put here the cloud cover, and then put the operator. I simply put the operator is that less than, and set the value for 1. Okay, I simply set the value for 1. Okay, so now I want to check for the region how many images are available which are less than 1% cloud cover. I want to check it. So just I simply use here the print function, and then simply call the filter metadata again, and I simply use a function. It's called the size function, and click the run. In this time, I get the result. How many images are available for this less than 1% cloud cover? Here I can find out total 20 images for my region, and this image is the less than 1% cloud cover. Okay. In this time, these 20 images are available for this time period. You can see year of 2021, 31 October from 2023, 1st January. But suppose I want to need the satellite images for year of 2022. A specific time period, I want to need the satellite images. A specific time period for year of 2022, I want to need this satellite image. So I also need to filter date. I also need to filter the date. Okay, so let's go. I just simply take a variable and put the variable name, suppose filter date. You can see from 20 images, I want to need only for those images which images are available for year of 2022. Okay, so just I simply call the filter metadata, because these 20 images are available in the filter metadata variable. I simply paste here. Okay, then I simply use a function. It's called the filter date function. Filter date. I simply put here the start date, suppose 2022, 1st January from 2022 December 31. Okay, in this time, I want to check how many images are available for this time period. I want to check it. So just I simply use a function, print function, and then call the filter date.
Only for two data, 22 January, and only two date, not period from two.
Yearly.
Only two.
For the
period.
1 year. 1 year.
Ah, 1 year. Oh,
yeah.
Okay.
I want to check how many images are available for the 1 year. Okay.
Yeah.
Then click the run. So now I can check how many images we can get for the only for the 1 year. I can get 19 images. Okay. For year of 2021, I want to get for the 19 images for this region. And in this time, what is the properties for this 19 images? You can see, first of all, these 19 images are available for the city of Sarkesi, as well as these 19 images are available for the year of 2020, year of 2022, as well as this 19 images is less than 1% cloud covered. Okay. Okay, you can see, first of all, I can take the large collection. Okay, I filter it according to my region. Here I find out 143 images. I also filter it according to the image properties, less than 1% cloud cover. Here I can get 20 images. I also filter it according to my time period. Here I can get 19 images. Okay, so this is the process for filtering. When you want to filter any satellite images, we go to the step by step. I filter. For the whole world, I can get this large image collection. For my region, I can get this. After, I also filter according to the image metadata, or I need the less than 1% cloud cover, I can get 20 images. Then I also need the only for the year of 2022 images. Here I can get 19 images.
Okay.
Okay.
But if we use surface reflectance, if we use top of atmospheric collection, what
Same,
we need to do?
same. All of the things will be same.
But we need to do some atmospheric correction or no?
No, we don't need. Because
If
yeah.
raw image,
So
image.
yeah, in this time here you can see all of the image collection, they are already due for the atmospheric correction. You can see
Okay.
atmospherically corrected surface reflectance and land surface temperature derived from the product Landsat 9. Okay, so
Okay.
it dataset already atmospherically corrected. Okay,
Oh, great.
and top of atmospheric, all of the things so we don't need to again for this, because this dataset already corrected. Now we can use the dataset, just we need to filter and we can easily use it. Also same for the top of atmospheric image collection, you can see. So you also try to do for your own self, for also for the top of it, you can see top of atmospheric. So you also try to do for yourself for filtering the top of atmospheric image collection. You can see Landsat 9, it is also top of atmospheric calibrated reflectance. Okay, so it's already all of the things corrected, all of the atmospheric correction already done. Okay, so that's why in this time we don't need to do again. So you also try to filter this Landsat 9 top of atmospheric image collection for your own self, and you also practice. Okay, same process, which process I want to show in here. Okay, in this time you can say I can get the 19 images. Okay, in this time I want to all of the images, you can check what's the time period you want to check. Okay, these 19 images are not captured at the same time of the year of 2022. This image is the capture for the different time period of the year. I want to need the time image acquisition time. I want to need, I just simply print this and call the filter date, and then simply click to the run. Now I can get the result for image acquisition time. Okay, you can see here I can get all of the image. You can see time, you can see all of the image, total 19 bands.
Okay.
Here you can see the first image I can get year of 2020, 5th January, February, March, April, May 5th May 25, you can see 25 2022, 8 25 14 February, you can see February 2020. So all of the date we can easily get from here, and all of the image has total 19 bands. You can check all of the band also, you can see. So here you can get the surface reflection band 1, band 2, band 3, band 4, band 6, band 7. Okay, band 10, we can get all of the band in here. Okay, so we can get all of the images. In this time, suppose you want to work with the any single image. Suppose you want to work with only for the image, which image are the capture for the time period year of 2022. Suppose 25 March 2020, March, you want to work only for this image. Just you can simply click on here. You can see it also provide the image ID. You can say ID. Just you can simply copy the ID. Simply copy, and then take a variable. So I simply take a variable. Suppose this variable name is that image, and I use the function ee.image, and then I simply paste this ID. Okay, which I copy. I simply add this map.add layer, and then I simply call the image and click the run. In this time, you can see one satellite tiles will be added for your region. In this time, you can see one tiles. This tiles is not cover your area. You can see it only covered this part, but our full region is not covered. You can see one tiles I want to get, but it's not covered. So mainly if it's the small region, then we can easily work with only for the one single image we can work. But in this time, it's a big region. Okay. So in this time, you can say I need also some other tiles also, such as other tiles I also need to add. Then if you want to, you can simply show the image look like this. You can see I simply click to here and add the visualization, such as you can see I want to add the B4, then B3 and B2. It is a true color composite and stress 98%. And then click on the apply. So now we can get the visualization of the satellite image. You can see we can get the very clear satellite imagery for this region, but this it's not cover my full region. Okay, this satellite image is not cover my full region. In this time, I want to make the median composite using all of the images, using total 19 images. I want to create the median composite and then make the image for my full boundary. For this, I just simply remove this. It's not needed for this time. I simply call the filter date and use here the median and click the run. In this time, you can see what happened. It covered my full region. You can see my full boundary or my full cities, it covered now. When I want to take the median composite from all of this, from total 19 images, so you can see the full tiles. You can see we can it also covered. My region is covered. Okay, you can see now it created the median composite and it also covered my fill up my full region of these cities. You can see. Okay, in this time here you can see total 1 2 3 4 all of the images, all of the tiles, total 19 images it created. In this time I can easily add here. Suppose I want to add here this band combination, such as band 4 B and 2 also is at 98%. Apply. So now you can check, I can get this satellite images look like this for the surface clip satellite images. In this time, I just use here the clip function. Okay, so just I simply use here the clip function. I simply use here the clip function. So clip with my shapefile. My shapefile is that. What is my shapefile? My shapefile is the city. This is my shapefile. I simply copy and just paste here and click the run. In this time, you can see I can get the result only for my boundary of the city's boundary. I can get only for the satellite images.
No, great. Very easy.
Okay, I can easily add here this band combinations, such as band 4, band 3, and band 2. Also stress 98% for better looking and apply. So now I can see I can get the satellite image only for my region.
No.
Okay, so now you can easily use this satellite image for making the land use, land cover classification, making the any types of remote sensing work you can easily do for this image collection. You can see.
Mijan, can I give you questions?
Please, yeah.
If we have some point with coordinate, how we can download to Google Earth Engine and display for on our map?
Yeah, we can do it. Yeah, you can see here.
Yeah, we can do it.
Here you can see the CSV file. You can see CSV file. Okay. So first of all, you can simply make the CSV file all of your coordinate, latitude and longitude. You can create it in a CSV file format. Okay. Then you can simply import this in source file and go to import the CSV file. Okay. Then we can easily show all of the point from the coordinate on the map. Okay. We need the coordinate in a CSV file format.
Okay. If I send you some coordinate, you can show me how.
Okay. You can send me this file. I also try to show you that how you can easily show the from the CSV file format, how you can easily add the point on the map.
Okay. I think the next lesson, yes, we can discuss it.
Okay, no problem. Okay. So you can send me this file. I also add this. Okay. In this time, you can say I can get this image look like this. And this is the Landsat 9 satellite imagery for the surface reflectance. Okay. And Landsat 9 satellite image, we can also get the more clear images than Landsat 8, Landsat 7. Okay, you can see this is the very clear satellite images. We can easily identify all of the features such as the cropland, build-up area, water body, as well as we can easily understand all of the things. Okay, we can get the very clear satellite images. And this satellite
And
image
we
is the
can
less
do
than 1% cloud cover we can get. Yeah.
okay. And we can do it is other systems, Sentinel, MODIS, the same.
Yeah. So I also try to show you the MODIS, Sentinel, all of the things I will be showing. In this time, you also try to do for your own self for filtering the Landsat 9, all of the images, such as you can see top of atmospherics, raw image, you can also filter. And also try to filter, you can see Landsat 8 also available. Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. You also try to follow the same process and then filter all of the image collection for the Landsat 8, Landsat 7, all of the things will be same for the Landsat
Okay.
filtering. As well as Sentinel, I also try to show you this later, how you can easily do the Sentinel, and also show the MODIS, how you can easily do this. Okay. In this time, you can see,
Okay.
I can get the satellite images, look like this. And you can easily use the different types of band combination. Suppose I want to use here the 5, then 4, then 3, okay, then apply. So now I can get the false color composite. You can see, okay. Mainly this composite we are using for identify the vegetation. In this time, water body showing as a black color. This type of black color identify the water body. And you can see the red color, dense red color identify the dense vegetation. Okay, as well as different types of band combination you can use. Suppose I can use at the B6, then B5 and B3 and click to the apply. Okay, so now you can see we can get also the some barren land. We can also get the some you can see this is the cropland. We can easily identify. So this is the cropland. Also this is the cropland. You can see this is the cropland. Okay, cropland is look like this. We can easily identify, and water body is look like the black color. So there is the different types of band combination we can easily using from here, and we can easily identify the different types of feature on the surface. So in this time I simply use the yeah. Any question you can ask me.
Yeah, I maybe I go to the future, but and we next we must to do legend and yeah, and export this map.
Yeah.
For example.
So in this time you can see I can get these satellite images. In this time I want to need the export these satellite images. I want to export. Suppose when I export these satellite images, I easily work with the other software using these satellite images. Okay, so we can easily export any types of satellite images from here. Okay, cloud free image. So I also try to show you this part. I can easily export these satellite images. So for this, you can see when you want to export these satellite images, we need to. Okay, so I also try to show you this part, and you can see we can get. You can simply import. You can see import. When you click the import, it will be imported in here. I simply copy this variable name and paste after the object name. So this is my object. I simply paste here. So now this visualization before 3.2 and 98%, it imported in my code editor. When I click to the run, I can get the same result because I import it. Okay. So when you want to add the visualization from here, and then you can simply add the import. Then it easily imported this visualization parameter in your code editor. Okay, we can easily work with this. You can see, you can get the very clear satellite images. Okay, so in this time, I try to show you that how you can easily export these satellite images, how you can easily export the different types of band from the satellite images. So let's go. So for this, you can see in this code, I want to use here the different types of function. When I want to use the filter bounds, I take a new variable. When I want to use the filter metadata, I take the another variable. When I use the filter date, I take the another variable. But if you want, you can take only for the one variable, and under this variable, you can put all of the function. I take only for the one variable, and in this under this variable, I put all of the function. So let's go how we can do this. So just I simply commenting all of the things because I also send you the practice code. So I simply commenting, just commenting. When I want to comment this, it will be not work. So I simply comment. Okay, I comment. So let's go. In this time, I take only for the one variable, and under this variable, I put all of the function. Okay. So for this,
Okay.